So, hi Sarah. Today I was just wondering, could we go through my topic portfolio assessment? So I have the topic of dynamic mechanisms.
Yep.
So I'll just show you my assessment here. So I'll just share my screen. So my assessment consists of two parts. So it's section C of the exam paper, and mine's question 1, dynamic mechanisms. So part 1 I said would be 20 marks. So the image on the right shows a Ferris wheel at the Summer Festival Sea Sessions in Bundoran in County Donegal. So the Ferris wheel has a radius of 8.4 metres. The wheel is shown in the diagram below, and the passenger carrying components are located in 30-degree intervals. So you are sitting in one of these passenger carrying components 4.2 metres above the ground, and you are labelled B. So here's where you're here, B.
Yep.
And the wheel rolls along the horizontal line XY, this line here. So first of all, we have to plot the locus of the point for B for one full rotation. So coming all the way around and back to B, and then for a half rotation, which would be over here. Then after you plot the locus for a full rotation, we now have to identify point C, where that would be located, the hop-on, hop-off point. So do you know how you get onto the Ferris wheel and you get off the Ferris wheel? There's always a point. So that's point C. So then part 2 is 25 marks. I incorporated a principle sheet to address mixed ability. So the first part of the question would be more ordinary level, and the second part would be higher level. Okay. So based on the question above, complete a principle sheet highlighting all the principles addressed in the question. Include all relevant information linking to this topic of dynamic mechanisms and linkages. So using sketches and notes, we'll try and create a visually appealing principle sheet to address and to show what this question itself addresses. So as you can see here, part 1 is 20 marks, part 2 is 25 marks, and then a total of 45 marks for the whole question.
Perfect.
So just before I show you the solution, do you actually know which trochoid we're actually using here in this question?
Is it an inferior trochoid?
Yeah, it is. And why is that?
Is that because the point P is on the inside of the circle, or point B?
Yeah, point B is on the inside of the circle, so that's exactly it. And then for the principle sheet, then can you maybe list a couple of principles addressed in this question that we can incorporate in our principle sheet?
Yeah, so the first one I can think of is the rotating the circles, or like moving the circles along a given line.
Yes.
Then the formation of the inferior trochoid.
Yes.
Triangulation.
Yep.
And the plotting of the locus, so like point B, and the cycloids.
Yeah, exactly. Well done. So then just here is my solution. So I drew it out. Here, when you rotate your circle along a given line, like you said, and we plot all the points along it. So this is plotting the locus. So as you can see, our point B is at the very end, and our point C is our hop-on, hop-off station.
Okay.
Then just here, a quick principle sheet that all the little things you can address in it, from your dividing your circles up into 30-60, your different types of trochoids, your cycloids, your keyword walls, all the things that you could use in to incorporate in this principle sheet. So then I have a resource just to help students understand the different we'll say for linkages. So here I just have a quick video made on GeoGebra. So as you can see, point A is fixed and point B is fixed, but point A is fixed and it rotates around the circle.
Yeah.
When this rotates around the circle, it pulls the point D along the line. And you can just do that again to understand the principle of the linkages. So you can see that the length of the lines never change. They're always going to be the same length. This kind of links back then to your Trammell method, how to plot the locus of your Trammell method.
Yeah, that's a good resource.
Have you any other questions for me?
That was a good question, that it addressed both like higher and ordinary level in your question. So yeah, no, it was very good.
Perfect. Thanks for that, Sarah.
No worries.